Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon, everybody. Thank you for joining me today for this engineering series talk. This is the second talk after yesterday's talk by Rj45. So my name is Prof. Dr. Muhammad Yusuf bin Alias from Faculty of Engineering, Multimedia University. So today we're going to continue our engineering series talk with another interesting topic for you, which hopefully will get your interest into engineering. It will be about Wi-Fi and you. Right? Hopefully, everybody is staying at home, staying safe with this first day of total lockdown. But it shouldn't stop us from learning something new and something interesting for all of us. Right? So now let me share my screen before I start my talk. Okay, so if you want to scan your attendance, you can scan the QR code on the side of my screen there. So that will be the attendance for today's talk. Yeah. All right. So I'm sure everybody is aware of Wi-Fi. Wi-Fi is everywhere nowadays, right? So if you go, not only that Wi-Fi is available at home, Wi-Fi is also available outside. If you go to Mama stall, you will start not just ordering food. Of course, during this lockdown, you are not able to go to Mama stalls anymore. But if you go to Mama stall, you're probably not just ordering food, but you will order what is the Wi-Fi password. Or if you go to someone's home, you will also ask, do you have a Wi-Fi, or do you have a Wi-Fi password that I can use? So everywhere that you go, to public places, to local vicinities, to airports, to even bus stations, you will get Wi-Fi services everywhere. And even to your favorite fast food restaurant, probably you will use Wi-Fi while ordering your famous BTS meal, right? So Wi-Fi is everywhere. So what is now the question will be, what is actually Wi-Fi? So when you switch on your handphone or your laptops, probably you will go to your Wi-Fi connection and start switching it on, and it says, oh, okay, Wi-Fi is connected. And you will get this Wi-Fi signals beaming in onto your devices, right? But have you ever thought, what is actually, or how does Wi-Fi actually works, right? So how is this signal coming in into your phone? Or how is this signal going to be generated, right? So the usage of Wi-Fi is everywhere today. So you're probably going to ask, or probably you don't want to ask, right? What is Wi-Fi and what does that have to do with you? So the main question is, how does Wi-Fi work, right? So before we actually go and continue and find out about how it works, we should know where it is. Where is this Wi-Fi coming from? What is the history behind Wi-Fi, right? And how did it all start? Yeah. Before the existence of Wi-Fi in the 1970s, people already started to create a network of computers. So this is the era where internet started back in the 1970s. At the University of Hawaii, for example, they created what is called the Aloha Net that connect computers together, and it will link into a server, where this server will be the one that will be connecting all the computers together, right? So researchers have been using computer networks since the 1970s, although for the public, it only started to become something that is used by the public back in the 1990s. So computers have been connected all this while, right? For the birth of internet back in the 1970s. So for the end user, for like us, we will have each user connected with cables to what is called a router or a switch, right? And this router will connect the computers to servers, and we will get to download, and we'll get to connect to the internet altogether. I'm sure you have seen an example of cables like this one. Right? This is called the Rj45 cable, and this cable is usually connected to your computers, and at the other end it will be connected to the routers, right? At the back of the routers like this. Okay, so these cables are called Rj45 cables or internet cables. You probably have seen this a lot before, right? And it's still around. People are still using it. But the problem with cables, once the internet started to boom and everybody started to use the internet, so you will have a lot of cables. You just imagine when you have so many cables around, then you will start to be entangled with all these cables around you, and it is not that convenient at all. So you don't want to have cables all around. The other problems with cable is that once you are connected with a cable to a device, and if you start to move around, you are actually restricted by the distance that the cable can carry you, which is also not that comfortable. In the olden days, most of the devices that are used are just computers, like the desktops, servers, etc., which are not really portable and are not really moving all around the places. But with the invention of laptops, small devices like your smartphones, etc., then having a cable is really not that convenient. So because of this, then researchers started to come out and think, oh, well, what can we do to get rid of all these cables or wire? So that's the idea when they started to think, oh, well, why not we come with a wireless system, something that doesn't have to be connected with cables. So that's when the system, instead of using cables, the stations where the for example the laptops, the desktops, or even like small devices like handphones, etc., can be connected to the internet, can be accessing the internet through the access points, but without having to be connected with cables. So that's the name wireless, right? Because it is no longer using wired, it's no longer using cables, so it's called wireless or wireless. So wireless, the idea of wireless actually started back in 1991. I'm not sure if any of you were born during that year. In 1991, in the Netherlands, they already started planning of inventing the what is called a wireless local area network. In the previous diagram, when we are connecting computers together, we call this as a local area network. So it will be connected to one router or one switch or one server, and then through the server it will be connected to the different end users, right? But with the system going wireless, so the end user or the endpoint is now replaced with wireless rather than having to be using any cables. So start is already 24 years since the first wireless local area network was launched in the market. So the term wireless, right? Of course, when you're talking about wireless local area network, people more familiar with the term Wi-Fi. So actually, the concept or the system itself is called wireless local area network. So what is Wi-Fi then? Is Wi-Fi the same as wireless local area network? Actually, Wi-Fi, the term Wi-Fi was only used starting from 1999, which is 2 years after the introduction of wireless local area network. The term Wi-Fi refers to, or in the long term, of course, even though they don't claim that Wi-Fi stands for wireless fidelity, but this is what is widely known. So Y, the WI is for wireless, Fi is for fidelity. So wireless fidelity or Wi-Fi is where you can actually use wireless everywhere. So the term Wi-Fi is referring to this wireless fidelity, and it's actually referring to a group of companies that form an alliance or a consortium. So among the companies are like Intel, Nokia, Ericsson, Motorola, and so on. These big companies, they form a consortium or a group of alliance called the Wi-Fi Alliance. So Wi-Fi Alliance is basically an association that hold the trademark for the term Wi-Fi. So that's why when you see this logo, even though if you go to a Mamak stall, it says Wi-Fi available and the Wi-Fi password, you will see there is a TM there. It's not Telecom Malaysia, it's a trademark. So this Wi-Fi is a trademark logo, and it is belong to the Wi-Fi Alliance. So what's the function of this Wi-Fi Alliance? Basically, they will come up with a certification called the Wi-Fi Certified. If you want to see it, you can see behind your laptop or behind your phones, for example, at the back of your phones or at the back of your laptop, you will see this logo called Wi-Fi Certified. It's very similar to when you see CRM or MCMC certified. So Wi-Fi certified is where the equipments have been certified by the Wi-Fi Alliance, right? But what about Wi-Fi equipment that is not certified by Wi-Fi Alliance? Basically, they won't have the Wi-Fi certified logo, but it still may be compatible with the Wi-Fi devices. The only thing is that it is not guaranteed. That means sometimes if you buy from online shopping like Shopee or Lazada, you go and buy a phone, a laptop, or any devices like dongle and so on that doesn't have the Wi-Fi certification. It doesn't mean that it will not work. It will work, but it is not guaranteed to work. And you will also notice that any equipment with the Wi-Fi certified is normally more expensive compared to the one without the non-Wi-Fi certified, because the process to go for certification is a bit more expensive. So they have to pay for the certification process. Oh well, that is a part of the business that they have done for the Wi-Fi. So the term Wi-Fi itself is actually more towards marketing, more towards the manufacturing usage, right? So the standard that Wi-Fi is using is actually the one that is produced by Institute for Electrical and Electronics Engineer, or IEEE. And this IEEE is basically a non-governmental agency or non-governmental organization based in the United States. But they have chapters, they have memberships everywhere. Even I'm a member of IEEE. So IEEE is actually a research association. So they are not really into businesses. So what they do is they come up with a standard, and this standard is the one that is used by the Wi-Fi Alliance. So the standard they are using, IEEE have a lot of standards. They have standards for cables, they have standards for USB, they have standards for other devices as well, even for power electronics, for robotics, etc. They have many standards for anything that is related to electronics and engineering. So one standard, or the standard that is related to wireless local area network, is called the IEEE 802.11. Well, this number is definitely not fancy, and no one wants to say, hey, can I have your IEEE 802.11 standard password? So it doesn't sound that catchy. It's not something that is really attractive to normal users like us. So that's why instead of using IEEE 802.11, because this is the standard that is adopted by Wi-Fi Alliance, so the term Wi-Fi is mostly used as a common term, even though it's actually referring to the alliance itself. So now you know the difference between Wi-Fi 802.11 and also wireless local area network. but the common term, like the common users like us, we definitely are using Wi-Fi as the term that is common. Okay, so since 1997, as you remember earlier, I said 1997 was the first year that IEEE 802.11 launched the standard for Wi-Fi or wireless local area network. Since then, for the past 24 years, there have been research ongoing. Then every improvement or every time they improve the system, then new standards come out, right? So from the beginning, they always give a number IEEE 802.11 with a certain number at the end. So at the beginning, there was 802.11a, 802.11b, 802.11g, 802.11n, and currently in the market, if you go to any supermarket, if you go to any shopping and you buy your access point, the one that they are using is called the IEEE 802.11ac, right? And even then, research are still ongoing. People are researchers like myself and also other researchers. We are still looking on how to improve this IEEE 802.11 standard. So there has been research in 802.11ax, AF, and so on, right? So of course, you don't need to know all the standards as end user. We never know like, oh, do you have 802.11n or 802.11g or 802.11ac? But it's actually, each of this standard actually carries different meaning and different specifications where it can also give different performance to the end user. Okay. So Wi-Fi is always confused with the word internet, right? Everybody thought that Wi-Fi and internet is the same thing, yeah, but it is not. The truth is, Wi-Fi is not internet, and internet is not Wi-Fi. So Wi-Fi is actually simply an alternative that connect the devices at the end user like us to the internet. So internet, if you go and Google or if you have learned before, internet is called internetworking. When there is an interface or internetworking between different devices like computers, laptops, handphones, etc. So Wi-Fi, on the other hand, is the one that is connected to the end user. And it is only a replacement to the local area network, which is the cable version. So Wi-Fi connects each of these devices, of the devices that you see at the end, whether it's laptops, mobile phones, tablets, PC, or even nowadays you have printers, etc., to what is called a router. And this router is the one that will be connected. Yeah, this is an example of a router. So perhaps you may have seen this router somewhere in your home, in mama store, or in any restaurants that you see. So this is called a router. So it's a Wi-Fi router. So what it does is that the router itself will be connected to the Ethernet, right? So the endpoint of the router, will be connected by cables to the internet. For example, if you subscribe like Unify at home, you will see there is a cable that will be connected to another device which is called the modem, and that modem will be connected to your fiber optics to the home, right? So the Wi-Fi router is also known as the access points. And from the access points, it will be connected to the user using radio signals instead of cables. So these end user are also called stations or devices, right? So Wi-Fi can actually be connected in two ways. And the one that we are normally used to, The one that we use at home is called an infrastructure mode, where the infrastructure mode, as I shown you earlier, you have an access point, which is the router, and this will be connected to the devices at the other end. And from the router, it will be connected to the internet, right? So, for example, if you subscribe to any fiber like Wi-Fi to the home, for example, it will be connected to the fiber and then connected to the main internet network. And if you connecting Wi-Fi to other services like the mobile network, etc., it will also be able to connect to that, right? Wi-Fi can also be connected in another mode, which is called an ad hoc mode, right? So perhaps you are not familiar with ad hoc mode, but I think you have been using ad hoc mode all this while. For example, when you set up a mobile hotspot. So mobile hotspot is an example of an ad hoc mode where you are actually connecting a device to another device, right? To another device using a Wi-Fi network. So this device can connect to each other without having to go to the public network or to the actual network itself, right? So this is called a mobile or an ad hoc mode. Right? Another example of ad hoc mode that you probably have used is when you actually use your smart TV, for example. Your smart TV connected to your phone, where you beam your phone screen, you share your screen with your smart TV. So that is also an example of an ad hoc network, right? So the one that is mostly common is called the infrastructure mode, which is the one that you are mostly using at home or in other places. So how does this Wi-Fi works, right? So Wi-Fi actually are using radio signals. So they are transmitting radio wave. So the messages will be transferred from devices using radio signals. Of course, you cannot see radio signals, right? So radio signals are something that you won't be able to see. It's an invisible wave that is carrying the message, and this message will be carried to the access points. So you will have the radio, the access points, and you have your mobile devices. So the mobile will be sending what is called data packets. So these data packets is the messages or block of data that will be sent and delivered to the access points through radio signals. As with any other radio signals, there are various ways, what we call modulating and demodulating of the carrier wave throughout the radio. Stations, each of these devices will have an address. Yeah, it's similar like your postal address, or your home address. It needs to find where to send and to receive. So every devices have their own address, which is called the MAC address. You can actually find your device MAC address when you go to the properties of your devices, and you will be able to find the address of your device, which is called the MAC address. So it's similar like your home address. So or in a network or in an internet, we sometimes call an IP address, but that is more specifically for internet protocol, right? So the MAC address are used to not only transmit, but also receiving the radio signals. So each of these devices will have a unique MAC address, right? So this Wi-Fi is established and it will be connected, and on the reception of the transmission, the receiver will use the destination address to determine which station to send to, right? So a network interface normally does not accept packets addressed to other users. So don't worry, the one that you will be receiving is specifically for that MAC address alone. It is not for other addresses, right? So the Wi-Fi client is the devices that you have, and it will be transmitting packets, yeah, from the station to the router or the access point, and from there it will be connected to the servers or to the networking. In the earlier days, there are many devices at the station itself. Of course, this is an example of the access point. I've already shown you the example of access point. There are many types of access point, and there are different versions of access point. For example, this is from TP-Link, right? This is right, and you may also have seen the extender, a network extender like this, right? Which is also used as an access points, right? On the user side, yeah, probably nowadays you don't see anything connected here, but most of the interfaces are already embedded in your motherboards, in the chips itself. There is already a chip, a Wi-Fi chip embedded on your phones. But in the olden days, people were using, like, for example, back in the 1990s, we used PCMCIA card. You will be also using, like, for example, the network interface card or NIC card, right, for desktops and so on. And nowadays, you can also purchase like the Wi-Fi dongle, something similar like this, right? This is a Wi-Fi dongle that you can just plug in into your USB, and you will be connected to your Wi-Fi access point or your Wi-Fi router, right? Okay. All right. So the nowadays, right, most devices, as you can see, for example, if you buy laptops, if you buy handphones, if you buy tablets, or if you buy PCs, for example, they already have Wi-Fi embedded in the devices. So there is no need to buy an extra devices just to connect to the Wi-Fi network. As we have seen earlier, right, there are many versions of Wi-Fi, right? So when we started, when Wi-Fi started, there was 802.11 A, there was 802.11b, G and N, A, and then there was AH and etc. Right? But the one that is very popular, in the difference between each of these standard is actually that the standards carry or using different frequency band, and frequency band is the one that is carrying the messages. So for example, in the 802.11ah is using 900 megahertz band. In the 802.11 BG and N is using 2.4 gigahertz, and 802.11 AC, right, is using 2.4 gigahertz or 5 gigahertz. And then you also have 802.11 AD using a very, very much higher frequency. It's 60 gigahertz. And there is also the 802.11 AF using 54 to 790 megahertz. So what's the difference between this different frequency band, right? Probably when you open or you switch on your Wi-Fi, you will notice there is there is a Wi-Fi for 2.4 gigahertz, and there is also a Wi-Fi for 5 gigahertz. Right? If you notice that you switch on, especially for the latest laptops or devices or handphones, you will have two frequency bands that is very common. There is a 2.4 gigahertz and there is a 5 gigahertz. So the lower frequency, the 2.4 gigahertz, is actually having a much bigger coverage. You just have to remember that the lower the frequency, the further the distance that it can travel. So it will be able to travel a much further distance. Whereas the higher frequency, it can travel only a short distance. Why is this so? Because the waveform itself, if you have taken physics or if you have learned physics, right, when there is a high frequency, the wave will be moving very fast. So the power of the wave will lose very fast as well. So when the power loses, it can only travel up to a certain distance. That is why the 5 gigahertz band can only cover a smaller area compared to the 2.4 gigahertz. After this, you probably can check your Wi-Fi at home. There is definitely a 2.4 gigahertz and there is a 5 gigahertz, right? So the difference between these two, why is 2.4 and 5 gigahertz is the common frequency band that is used for Wi-Fi. Actually, 2.4 gigahertz and 5 gigahertz are called the industrial, scientific and medical, or ISM band. And this band is actually free to use. So there is no license that you need to pay in order to use this frequency band. So that is why 2.4 gigahertz and 5 gigahertz is the most common band, right? But what would be the difference between 2.4 gigahertz and 5 gigahertz other than the coverage? 2.4 gigahertz can carry a smaller amount of data compared to the 5 gigahertz. So if you go and search, for example, you can use apps that is available in your Androids and in your iOS devices. You can look at the speed. There is you can even search, like for example, Ookla and so on, that you can search for the speed. You will notice that if you use 2.4 gigahertz, you will get a lower speed compared to when you use 5 gigahertz. So each of these has its own advantages and disadvantages. 2.4 gigahertz can travel further, but the data rate is smaller. Whereas the 5 gigahertz, on the other hand, can travel shorter distance, but it can carry a much higher data rate. So depending on if you want to have a further distance or if you do want to have a higher data rate, so you will have to switch between 2.4 gigahertz and also the 5 gigahertz, right? Probably you can also notice when you are at home, right? The frequency band that you will use will determine the range that you can reach at your home, right? Depending on where your access point is located. For example, if you're living in a 2-story house, if your access point is on the upper floor, you will notice that when you go down to the lower floor, the signal is deteriorated, right? But if you use 2.4 gigahertz, you may still able to get or reach these signals even in your kitchen or even if you go down to your living room. But if you use 5 gigahertz, you may not be able to receive the signals. So the different frequency bands have a different range, right? The further you are from the access points, the smaller the signals that you will receive. So probably you will notice that if you're very close to the access point, you will get 5 bars in your Wi-Fi. But when you are moving further from the access point, your signal starts to go down from 5 to 3, 4 to 3 to 2, and even at one point there is no Wi-Fi signals available, right? So this is actually very common to any radio signals, any wireless signals, because as with the other radio signals, the radio will be affected by the environment. So this is one of the disadvantages of radio compared to cable, because radio, as you move a further distance, you will get a lower signal power. Moreover, it is also affected by the environment, such as the walls. Even the materials that you use for the walls will actually determine the signal strength as well. If the walls is very thick, then your signals may not be able to go through the walls, right? So there are also other effects, such as the surrounding areas, such as the furniture that you have in the house. If you go outside, the trees, the buildings, right? Everything is going to affect your signal strength, right? So one of the ways to solve this problem, if you actually have a Wi-Fi at home, especially if you have a big home, like even in offices, if you have a big office or if you have a big house, one of the ways to solve this problem in order to get connection in remote areas like in your kitchen, or if you go to some bedrooms and so on, you can use what is called the Wi-Fi extender, right? So this Wi-Fi extender can actually become a repeater, and it can actually strengthen the signals again. So it will be able to boost the signals. When it receives the weak signals, it will be able to boost the signals in the area that you want to cover. Another way is also called the mesh network. So it's very similar, almost similar like the extender, where it can actually cover a bigger area. So this is one of the ways to cover a bigger area and to actually boost your signals. Another way that you can boost your signals, in the olden days, the access points is using one antenna. Most of the access points available is using only one antenna. But nowadays, you will notice that some of the access points are coming with what is called a multiple antennas, right? So the more number of antennas that you have, the stronger the signals that you can get. So in this example, if you are using 5 gigahertz, you will be able to reach up to even 1.2 gigahertz of or gigabits per second of data, compared to the 2.4, where you can only reach about 500 megabits per second, right? But in the end, it still depends. Even if your Wi-Fi can reach to 1.2 gigabits per second, it will still depends on the type of network that you have. Because if your endpoint or your end user here, if the one that is connected to the actual network is not up to 1.2 gigabits per second, even though your router can go up to 1.2 gigabits per second, the bottleneck is still going to come to the one that is connected to the network. So for example, if you subscribe to a unified service with a 30 megabits per second, of course nowadays is 100 megabits per second or 300 megabits per second, right? If you take the package of 300 megabits per second, even though your router can go to 1.2 gigabits per second, your data will still be limited by the 300 megabits per second that you subscribe to, right? So in the end, it will still be dependent on your the one that is connected to the main switch, right? So the usage of these multiple antennas has actually helped a lot, because it's not only to increase the coverage, but it can also increase the data rate that is being sent. But another point that is using these multiple antennas is because there will be a lot of interference. Have you ever noticed that when you switch on your Wi-Fi on your phone, there is a huge list of access points that is available surrounding your area? There will be access point coming from your neighbors, right? There are, if all your neighbors actually, especially in areas like high-rise buildings, apartments, and so on, you will notice that you will get a lot of this interference. So these interference are called the co-channel interference or the adjacent channel interference. For the 2.4 gigahertz and also for the 5 gigahertz, there are actually a few channels that is available. But unfortunately, some or most of us are not aware of what are the channels that is available for us. You can actually set up your own channel, whether you want to use channel 1, channel 2, channel 3, channel 4, or channel 5. But normally it will be set by default, right? So what can actually this interference cause to you? Sometimes you will notice that your Wi-Fi signals is not able to go through, so your signal will be blocked. And sometimes your speed will be lowered, because the fact is that when there are many Wi-Fi around, each of these Wi-Fi signals will start to interfere with each other. And this is because we are using radio signals. We are using air as the medium. And air is free for anybody to use. So there is no way that you can control which signals can come in or which signals can come out. The good thing is that in Wi-Fi, we use what is called the Carrier Sense Multiple Access, or CSMA, with collision avoidance. So with this, it will be able to listen before transmitting. And if it listens that somebody else is using the radio, it will stop the radio, or it will delay the transmission of the packets until the noise is gone, right? So this is one of the way that you can reduce the interference. Another way that you can reduce the interference, if you know how to set your own Wi-Fi access points, actually you can program your access points. Each access points is programmable, so you can Google for it, like for example, and you can find the password or the MAC ID of the access points at the back of your access points, if you can see here. So the information about your access points is at the back of the access points, right? Okay, so you can program your access points such that your channel doesn't overlap with your neighboring channels. So for example, you can set your channel to be channel 1 or channel 6 or channel 11, so you don't interfere with your neighboring signals. So this is one way to avoid the interference, right? Another problem with Wi-Fi nowadays is because there are too many users. So this contribute to the congestion on certain channels, right? Everybody is using Wi-Fi. You have a lot of devices using Wi-Fi. So we call this Wi-Fi pollution. So or you can call it Wi-Fi pollution. So these issues can be very serious, especially when you are in high density areas like large apartments, complexes, office buildings, and so on. Okay. Other than this interference coming from the user using Wi-Fi, you will also get interference from other devices that are using the frequency band. As I mentioned in the earlier slides, 2.4 gigahertz is a free unlicensed spectrum band. So that means anybody can use it. And basically, a lot of people have been using it. One good example is your own microwave oven. Do you know that your microwave oven is actually using 2.4 gigahertz frequency band? So if you are actually using your devices next to your microwave oven, there is a huge interference on your Wi-Fi signals if you're using 2.4 gigahertz. Another example of a 2.4 gigahertz is your Bluetooth headset. So if you're using Bluetooth, whether it's a Bluetooth headset or whether it's a Bluetooth speaker, even if you use Bluetooth on your handphone, you will notice that there will be an interference towards your Wi-Fi signal as well, because Bluetooth is also using 2.4 gigahertz. Other than that, there are many other devices such as cordless phones, even baby monitors, the one that people are using in their homes for babies, yeah, when they have like walkie-talkie, your smart TV, there's even amateur radio, this is a cordless headphone, and so on. These are using 2.4 gigahertz that may be interfering with your Wi-Fi signals. Even security cameras like IPTV cameras or IP cameras is using 2.4 gigahertz, right? So all this will contribute towards interference of your radio signals or your Wi-Fi signals. For the 5 gigahertz, some interference will be coming from, for example, from radar. But of course, there is not that much interference because the 5 gigahertz can cover a small area. So meaning it won't be able to be getting any interference coming from the outside. Okay. Right. So the question when you have Wi-Fi, and most people were asking, is probably is our Wi-Fi signal secure, right? So Wi-Fi signals is using air as the medium. So therefore, that you have to understand air is open. Anybody can actually use the air. People can be hiding behind trees and they can listen to your signals. People can be hiding in their cars and they can detect your signals. Just like you can scan your neighboring Wi-Fi signals, right? It's similar, like anybody can actually determine your or can actually detect your Wi-Fi signals. The good thing is that this security measure has been taken by researchers when they started to plan for Wi-Fi signals. So there are a few security measures in Wi-Fi. For example, you can set your access point in a certain SSID. So SSID is like the name of your access point. So when you try to access when you switch on your Wi-Fi, you will notice there is a list of access points that are available. So this name is called SSID, right? So SSID can also be hidden. So one way to secure your access point, if you don't want your neighbors to see your access point, what you can do is you can set your SSID to be hidden. That means you are not broadcasting your SSID. So how are you going to find it? The only way is that for you to key in the name of the SSID specifically. So only those people who know the name of the SSID will be able to connect or will be able to find the access point. Another security measure that has been done for Wi-Fi is that they have a key. So this is the password that you key in into the SSID. So there is an encryption for the SSID. There is two types of encryption. Previously, it was using wired equivalent privacy or WEP, and nowadays they have used a much more secured encryption. Is called the Wi-Fi Protected Access or WPA and WPA2. So it's very secure, right? Another thing that you don't need to worry is people would not be able to tap into your signals and listen to your conversation, because all the signals that are transmitting through the air will be encrypted. When will be encrypted, you just imagine similar like when all the codes are using some secret messages or secret codes that nobody will understand except for the devices that send and also receive. So your signals is very secure. So there are a few measures of how to secure your signals. One is hiding the SSID. Secondly is setting up the password. Nowadays, I think everybody will set up their password for their access point so that nobody can use it publicly. In the old days, when people are not aware about the security, you can find a lot of the access points are publicly available and people can just simply borrow the Wi-Fi from their neighbors, right? Another question that probably would have come out when people are talking about Wi-Fi is definitely about health. Whether Wi-Fi is creating any side effects or any health hazards. Is it going to hurt me with my health, or is it going to cause me any problems with my health? The good news is that World Health Organization has already declared that there is no health effects that is expected from exposure to radio frequency fields from any base stations of a wireless network. This is because the radio that we are using, the frequency band that we are using, is using 2.4 gigahertz and 5 gigahertz, which is also called the non-ionizing frequency band. So when we are using non-ionizing frequency band, it will not affect your cells at all. So you don't need to worry about it. The other thing is that Wi-Fi power is very low. So it's not going to cause any problems to your skin, to your health, or anything like that. So the power that is emitted by Wi-Fi is actually even lower than the power that is emitted by your handphone or by the base station and the handphone. So there's nothing to worry about the radio signals that is coming out from your Wi-Fi. So hopefully, right? So there are a lot of things to learn. Hopefully, whatever that is explained is going to help you a lot. So Wi-Fi is only a small unit from telecommunication. It's only a small part from wireless communication itself. Other than Wi-Fi, you have cellular telecommunication, which I will be giving the same talk again on this Thursday. If you're interested about cellular network or about handphones, how handphone works, all right? So a handphone is another type of wireless network. So what is it different from Wi-Fi? Then you have to watch me on Thursday. So these are only a small portion of the whole telecommunication itself. So telecommunication is big, right? There are so many interesting things to explore, and there's so many interesting things that you can learn. And it also evolved our daily life. You use handphones, you use smartphones nowadays, you use laptops, you use PC, that are all using telecommunications. And with more and more devices coming in, like your smartwatches, you have Bluetooth headsets, you have your Bluetooth speakers, etc. There are many wireless systems coming out in the market, and you can imagine, like, people are talking about 5G, people are talking about fiber network. So telecommunication is such an interesting, and it will never, it is definitely going to evolve in a long time. So telecommunication is a huge area that can still be ventured. And if you are interested, we have a program called a Bachelor of Engineering Electronics, majoring in telecommunication, that will take you and teach you everything about telecommunication, especially all the current ones like 5G, etc. Right? So this is just another program, and about the area is big, and there is a huge potential in the future. So you don't need to worry about not having work, for example, not having any jobs in the future, because people will be using telecommunication even if they have robots, etc. in the future, right? So that will be the end of my slides. Sorry for taking too long of your time. I really hope that you have learned something. In case for those who have not been able to scan earlier for the attendance, I've already displayed the QR code once again. So you can scan the QR code, and this QR code is important because you want to get your e-certificate, right? I'm sure you do need this, right? Especially when you want to go in further later on. Let me see if there is any questions. Thank you to those that are watching me on YouTube Live. Sivanidian, Sakti, Eshvarhin. There's a lot of people saying hi here and there, right? Not that many questions. I can also see people on Facebook Live. And there are also some people on Facebook Live, right? But if you do have any questions, you can always watch us. You can always go to FOE Instagram at MMUFOE. Sorry, the Instagram is MMU Engineering, right? It's on the site that you cannot see. And if you can also go to our Facebook at MMUFOE, right? And you can always come to MMU website, www.mmu.edu.my. So once again, thank you very much for your time. Hopefully everybody has gained something from this talk that I've given. And don't forget, there is another talk that's coming Friday. There is a question on YouTube Live. Ash Varhen was asking what is the difference between Wi-Fi and fiber. So Wi-Fi is wireless, right? Fiber is cables. So there is a difference between cable and wireless. Let me go again to this slide. I think I can only answer this one questions for now. Okay. So Wi-Fi is only the end user, right? At this point, where it is connecting the user, the end user, like our end devices, like laptops, mobile phone, and tablets, to what is called the Wi-Fi router. So this is the only portion of Wi-Fi. Whereas fiber is the cable, is the fiber optics that is connected. If you have subscribed, for example, for Unified Fiber services, you will notice that there is a modem that is connected to the line outside to the internet that is using fiber. So fiber is like a cable, but it's using a fiber optics, and fiber is like glasses, right? Okay. So I think that's the question. The only questions that I can answer for now is already 3 o'clock. Once again, thank you so much. Right? Wi-Fi is not wireless fiber. Right? Fiber is a cable. Wi-Fi is wireless fidelity. Right? Um, it's not wireless fiber. Forever who answered that one. So Wi-Fi is not wireless fiber. Once again. Okay, so hopefully that will give you, that's the only time that we have for now, is only 1 hour. If you are really interested in more of this topic, come and join us in MMU. You can always talk to me. There's so many things to tell, and there is so little time to tell. So there's a lot of interesting things that you can find out. Okay, with that, I would like to thank everybody for joining me today. Thank you once again. And if you are interested to see me again, I will have another talk on this Thursday from 2 to 3 p.m. on how handphone works or how mobile phone works. Okay, thank you. Assalamualaikum and have a very good day. Stay safe, everybody, and stay home.